Let's take a look. X-Intercepts. Who remembers how to find the X-Intercept? You have to set the whole thing. You're setting y equal to 0, right? And if you set y to 0, what you're really doing is setting the top part equal to 0. Now, I just happened to look over, and I noticed the fill in the blank, which doesn't have any fill in the blanks. But somewhere around here, the answers to the fill in the blank were there. This sheet here. I only have one left. But you should have a sheet that looks very similar to this. For those of you that can't see it because you're watching at home because you didn't come to class, don't worry about it. I'll take care of you. I gave you this Chapter 4 guide. And this would have told you how to find the x-intercepts. You find out when you set the top equal to 0. So again, use that guide. I mean, if you've lost it, let me know and I'll get you another one. But use that guide. It should help you figure out how to find all of these pieces that you need to know. Okay. So we're going to set the top piece equal to 0. If the Gators don't win the championship this year, that's going to require you to use the quadratic formula. As long as the Gators are winning, you'll still be able to factor, okay? Just know when you see them lose, you better memorize the quadratic formula. What's that? So we're going to go x minus 8, x plus 2. Yes, we did have a song for that. X minus 8, x plus 2 is equal to 0. So we're going to get x-intercepts of 8, 0, and negative 2, 0. An alternative answer, if you're trying to write an alternative answer, if you wrote x equals 8 and negative 2 like that, I'd give you credit. Okay? I mean, let's just be honest. If I didn't give you credit, I'd just be a jerk.
So if the Gators lose?
If the Gators lose, it's minus 5, for sure. No, I mean, I'd give you credit either way. Okay. Y-intercept. How do you find the y-intercept? Again, if you go to that sheet to find the y-intercept, set x equal to 0. Okay. So plug it in x is 0. You're going to get 0, 0, 0, 0. What you're ultimately going to get is negative 16 over 6. And y'all can't read that worth a damn. Yeah, let's don't even pretend you can read that. Let's try a different color. 0, 0, 0, 0. People like this, anything but red. Negative 16 over 6. And you can reduce that to negative 8 thirds. Okay. Yes, if you put y equals negative 8 thirds, that's the same thing. Okay. Vertical asymptote. Vertical asymptote is somewhere around here. And the vertical asymptote will exist when the denominator is equal to 0. So to find the vertical asymptote, you're going to want to set the denominator equal to 0. To find the vertical asymptote, set the denominator equal to 0. So you're going to get 3x squared plus 11x plus 6 is equal to 0. You're going to get 3x and x, 2 and 3. Hopefully that gives you 11x. 2x and not 3x is 9x, so it's 11x. So solving those two independently, you'll get x equals negative 3 and x equals negative 2 thirds. Now again, I remind you that if you forget this x right here, Don't worry about it. I'll put it for you. And some of you forgot it on the axis of symmetry last time. I told you don't forget the x, and if you do, don't worry about it. I'll put it for you. I totally took care of it for you. Okay, please don't forget the x equals. Okay, it's not just -3 and -2/3. It's x equals. Vertical asymptotes are an equation. Okay. Now, to find the horizontal asymptote, again, you can go back to that sheet. Horizontal asymptotes. Horizontal asymptotes are, look at the degree on top and degree on bottom. If they're the same, it's y equals whatever the coefficients out front are. So since these are the same numbers, since these are both x squared, it'll be y equals whatever this ratio is, 1/3. Yes.
The vertical asymptote, -3, should we cross it out since technically it would make the denominator equal to 0?
It does make the denominator equal to 0. So let me just repeat the question for the people at home. The question was, since -3 makes the denominator 0, shouldn't we just not use it? Because we can't use -3 if it makes the denominator 0. And you're right, we cannot. But remember that a vertical asymptote, what the idea of a vertical asymptote is that it's that imaginary line. Remember, I used the electric fence example, right? And I was so proud of the dog this morning because she went outside and so I was walking by and she went running. She didn't have her collar on and she stopped. And I was like, good job. You didn't have to get shocked to do that. But remember, we were coming up to it, and then we were like, oh, hell, we can't get shocked, and we just started going up. That vertical asymptote means the graph won't hit that value. So you're right, it won't hit that value, and that's the value that it won't hit. So, no, we're not crossing it off. We're going up to it and not touching it. Okay? And so that's the answers for those 4. Okay? I say this, if you don't have this sheet, I think I might have a couple extra ones up here somewhere. And if not, we'll get you a copy of it, the sheet that has the guide on it. Okay. All right. Let's look at the next one. This one, some of you would have used your calculators, and if you did, cheater. What did you get? How did you do it? What is it? Oh, yeah, calculator. Calculator will get it for sure. Except it's on the non-calculated portion of the test. Now you're screwed. Yes, you can just do what it tells you to do. Make it the square root of 81 raised to the -3rd power. What's the square root of 81? And 9 raised to the -3rd power is 1/729. Because 9 times 9 times 9, this is 81 times 9 is 729.
What does the 2 tell you?
Say it again, please.
What does the 2 tell you?
So the question is, what does this 2 tell me? That tells me it's the square root. Now, say, for example, this is 125 to the -2/3. Then what I would do there is the cube root of 125 to the -2. So that would be 5 to the -2, which is 1/25. Make sense? Any questions on that? Who remembers? This is what we ended class with last time. Who remembers how to find the domain of a radical? Now, some of you would have done that by shifting the graph. I don't want you to do that. How do you find it?
Set it to greater than or equal to 0.
Set, and when she says it, what she really means is the radicand. There's your 50-cent word for the day. I want you to find some place in your life next week that you can mix the word radicand into a daily conversation. But don't force it. You know, I mean, don't be like, hey, Mom, we talked about radicand. No, I just want it to be like, oh, my God, that was like so radicand. I don't know that you can do it. I just don't know that you can do it. Josh, Chick-fil-A, come over to the speaker.
Yeah, say radicand.
Radicand help you?
Oh, yeah, they would miss.
Ed would not even care. He'd think it was funny. All right. He'd probably give you a raise. Or fire you, one or the other. All right. X minus 4 is greater than or equal to 0. Add 4, add 4. X is greater than or equal to 4. So this one is 4 to infinity. Okay. Again, I go back to, is this easy or is this hard? And I would say the answer is, if you know the answer. If you know how to do it, you look at it and go like this. Oh, that's pretty easy. If you don't know how to do it, you go like this. What the hell's domain? What's the range? The domain is 4 to infinity. What's the range? 0 to infinity. Nice job. Why is it 0 to infinity? Remember the square root. That's like kale, right? It's this one. Okay, you got to know what that picture looks like. When you shift it to the right 4 units, it's not going up and down at all. It's all you're doing is going right 4 units. You're not moving it up or down. And so the range doesn't change any. Okay. For some of you in the back, let me pull that up. There you go. All right. What is this one? I'll tell you what. This is the Tim for today. All right, we're back. That was fun. Should have been here for that. All right, so we got, how do we find the domain of 16 minus x squared? We're going to say 16 minus x squared is greater than or equal to 0. Now, here's my question. What does this as a graph look like? If I said you sketch that graph, what does that graph look like? No. This looks like a half circle. I have no idea how you know that. What does this look like? 16 minus x squared. If I told you to graph 16 minus x squared, what would that look like? The baseball player knows. It's a downward parabola. Looks like this. Where does it cross? It crosses at -4 and 4. Right? Crossing at -4 and 4. Now, where is it greater than or equal to 0? It is greater than or equal to 0 here. Okay. From -4 to 4. Kindergarten writing. One of those fat pencils. Okay. -4 to 4. Any questions on that? Do keep in mind that I can ask you any, like here I just asked you 16 minus x squared. I could ask you anything. X squared minus 16, 4 minus x over 4 plus x. I mean, the number of functions that I can stick in here are endless. Okay, people were like, show them to me. I just told you they were endless. Okay? Anything can go in there. All right. With that being said, let's move to the next one. X plus 4 equals 6. Who's got an answer? Now, I haven't even talked to y'all about how to do that yet, but who's got an answer? Clarissa? And how did you get that? I mean, she said the answer was x equals 32. And 32 plus 4 is 36, and the square root of 36 is 6. But, I mean, did you just, go through the numbers? Like 1, no. 2, no. So you square both sides. So when you have a problem like square root equals something, you square both sides. And so you get x plus 4 equals 6, 36. Then you subtract 4, and you get x equals 32. Now, that certainly seems to work. But here's my question. Can you legitimately just square both sides every time and somehow get the right answer? Or is that a Timo? Now, Robert's going like this. The mere fact that you asked the question must mean the answer is no. Because you wouldn't ask if it was true. Very predictable, I guess.
Yes. Isn't there some sort of rule, like, because you can't get a negative number somewhere in the middle of that?
So that's our question. If I said to you x plus 4 was equal to negative 6, could I square both sides then? Well, let's look. Here's square x plus 4 equals 36. Yeah, baby. They had Austin Power sound effect. X equals 32, right? Yeah. Watch this. Fireworks going everywhere. Yay! But here's the problem. If you plug 32 in, if you plug in 32, is the square root of 32 plus 4 equal to negative 6? No. So the answer to this question is no solution. So the question now is, okay, well, clearly squaring both sides doesn't always work. When will it work? It'll work as long as what? Yes. It works as long as this piece here is positive. It will not work if that piece is negative. Does everybody see that? So if I said to you, all right, well, we want to solve square root of 2x plus 5 equals 4. Square root of 3x minus 7 equals negative 2. What are you going to do? For this one, you are going to square both sides. For this one, you're going to do what? No solution, and you quit. Okay? But again, I submit to you that this no solution is different than the ones you've had before. You see, back in your early infancy days of math, I know some of you look back with those years with great longing of how nice things used to be. But remember, when did no solution occur? Back in the day, this is what would happen. You'd be solving, you're just getting your hang of solving. You're like, minus 3x, minus 3x. Uh-oh. This is bad. And that would go, well, I guess I'll just put no solution then. Something happened that kind of gave away that the answer was no solution, right? Here, nothing ever happens. No red flag goes up. No, unless you're really close to God, no like, stop. Right? I mean, nothing happens that makes you think, look, y'all know some of y'all would like that, right? You'd be in the middle of working. Just kidding. Okay? Nothing would ever happen that would signify to you that this is a problem. Right? You would just square, and trust me, I say this and y'all are laughing. Some of y'all are going to do it on the test. I mean, I ain't calling anybody out by name, Josh. But somebody's going to square both sides and feel real good about themselves. I got the answer. No, you didn't. Okay? It's got to be a positive number if you're going to square both sides. What is, how'd you do this one? This one, you're going to cube both sides. You're going to get 2x minus 3 equals 5 cubed is, you didn't even use your fingers or anything. Now, how do you solve? Add 3, add 3. You guys take a break, I'll take it from here. 2x equals 128. Divide by 2, divide by 2. X equals 64. All right, with that being said,